computer. All right, so this is going to be kind of partially instructions for our Zoom exam, as well as any questions you may have in a review of just like some top 3 things for IR and NMR. All right, let's see. Those 2 are. All right, so that being said, let me go ahead and pull up my email where I have that sent. Uh-oh. Oh, Neil is joining. Okay, there we go. That's okay. Sent items. I thought I better send out very detailed instructions since this is the first time we're going to do it. And I thought we'd try a mock Zoom exam so you can kind of see what it's going to look like. And so that way I've sent out the instructions on how to get the Zoom app on your device. Let me see, I got to use my phone for this. And so what I found was that it's best to log in through the SSO, so that's through Texas State. And then you'll get that Duo as the verification, but that way you get to access Canvas and everything. And so that gives you, you're not limited to 40 minutes. If you're using a private login, you're limited to 40 minutes and it will log you out. And then that'll be a problem because you'll have to log back in. So that being said, log in through your SSO. And so I hope everybody has a device that can do this. I have an iPad and a phone for this. I know that any phone with a camera will do it, and any tablet should be able to do this. So the idea is to go ahead and set it up so that we can do that proctoring. So as per the instructions, you get signed in. And here, I'm going to turn my, I need to turn off my background if I'm going to do this. Let me turn off not my video. My background, none, there we go. So actually I'm in this dingy brown room here. This is my YouTube studio. But if I turn my computer slightly this way, what we're going to see is that by putting our devices sideways like this against something like a cup of coffee, you can actually see the screen of the computer, and where you're working at. That's the target. That's why we want, what I want to see is that I want to see you working through the book, flipping back and forth, and writing stuff down on the paper. And when you log in to Canvas, that's where you'll see the pictures up there, and the great thing about that is then you can expand them and contract them, and so you can actually look for things that you're not sure there. You'll be able to get a kind of a finer detail on them because the structures will be digital, and so that'll be kind of good. So so what I've been able to do with just my phone, I tried this earlier today, and we're going to try this today because I set up a meeting, and so that's at the bottom of that email where we can try to do this for everybody who has it. If you don't already have it set up, that's fine. Let's just try to get it set up over the next couple days, and either ping me and so that we can set up a meeting together, or use one of your friends who also has Zoom so that you can see each other and see what's going on. So the process again is we'll get the camera on the Zoom device on, preferably plugged in so that you don't want it to die halfway through. And then it's about 24 inches away. It gives you a view of the screen, the keyboard, and your work surface. That seemed to work best over the summer when we did this. Some of you who are SIs might have seen the training for this Zoom proctoring. That was part of the SI and the IA training this year is Zoom proctoring. So you might see that or already know even better than this. For the exam, we'll all log in using our devices, our alternate devices, and get that set up so that we can have the screen view and everything. Once I get to that view, what I'll do is I'll actually put on gallery mode on my side and just record. And so what it'll do there is it'll let me, have, no suspicion that you're not cheating, that you're just doing the work and it's all your own. And so that's what I'm hoping for, and I'll have digital evidence to prove that that's true. So that's great. Once that is done, we'll go ahead and open Canvas and open the exam under Files. And so that file won't be posted until right before exam time, probably 11:59. So I will upload it as soon as I open the Zoom channel for me. Then I'll go ahead and we'll go ahead and work on it, and then you'll have, once you're done, you go ahead and log out, and you have 20 minutes to upload that scanned copy to, or pictures of that thing, to Canvas under assignments. It's assignments, and it has exam 1, and it has a time limit on it, so it will time out if you don't get it in on time. Okay. So what I'm hoping to see is this next section here. The best way for me to give partial credit is to make a list of your observations. That doesn't mean write out full sentences. No, bulleted list, draw fragments, draw functional groups. I mean, kind of on this side, I want to see your thought processes. But things you should typically have on there is your first parent ion peak, your starting empirical formula based on your rule of 13, and if the masses, if the carbon, and if the M and M+1 values are given, you can actually estimate carbon there. Possible functional groups based on the IR. And then from that, you should get a working empirical formula. You've done your substitutions, you have a nitrogen or a chlorine or an oxygen, and you've done your substitutions. That's what your working empirical formula would be. And then go ahead and calculate your working hydrogen deficiency index. Then look at your major fragments. Okay, you can draw those out as things, or just draw them as the carbon 2, nitrogen 5, and those are fragments you see, not fragments lost. If you want to draw fragments lost on a different column, that's fine. I won't. That's not a problem. And then at the end, you need to have a proposed structure somewhere. But for each and every answer, I want you to circle the empirical formula of your final choice, the hydrogen deficiency index of your final choice, and the drawn structure of your final choice. If you circle those 3 things with all that other stuff on the page, I'll know exactly what to grade, and then I can look through and see what your thought process was on how you got there. Okay, so that's what I'm looking for. It's basically kind of like how we've been doing problems anyway. It's just you're going to have and depending on how big or small you write, you can do it all 1 page per test question. I'm fine with that. It's digital, so it's not like I'm gonna have a stack of paper on my desk or anything. So, and then move on to question 2 and just keep going. For the undergraduates, you're gonna have 5 questions, and for the graduate students, you're gonna have 6 questions. So there will be 2 exams listed on the files. One is going to be for 4333, which is the undergraduate version of the course, and one's going to be listed under 5333. So make sure you open and do the correct one for whether or not you're taking the graduate version of the course or not. Okay, so there should be 3 people taking the graduate version and everybody else taking the undergraduate version. Okay, so any questions on how to take this test? Okay, let's see. Neil is here. Okay, he's fallen off the screen here. Let me change over. Oh, there you are. Okay, I see you now. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Oh, somebody just left. Okay, we're almost all here. There's someone missing. There should be 8 students plus me. So we'll see. Okay, so any questions about that? Okay, if you have trouble getting a secondary device or something like that, contact me and we'll figure out something. Okay, on the homework, you had listed stating the formula and empirical formula. Starting formula is the version with only carbons and hydrogens after using the rule of 13. That is correct. That's where you start, because you can't do any substitutions until you have that initial mass. Then you look at the IR and say, hey, I got a functional group, so I'm probably going to have to substitute this atom or that atom or these atoms. And then that gives you your working empirical formula. Okay, so those are the terms that I'd like to use there. And again, it's going to be exactly like our in-class problems, where you're going to have an IR and a mass spec, and that's it. Okay. If it's something really challenging, I might give you a hint that it has a certain element in it, but I think with the IR, you do not need that. You should be able to identify those. But so I'm probably not going to give you anything but the IR and the mass spec. I think you can figure it out. Okay, and you'll have the entire hour and 20 minutes to work on it. So you will need our textbook, scratch paper, and a non-graphing calculator. That is correct. Yeah, calculator's fine. It's better to use a calculator than accidentally add a 10 to it and not know what the fragment is anymore. So yeah, a simple calculator, a bunch of paper. So if you want to do 1 page per problem, that's fine, you know. And then you can have a secondary piece that you just write on until you're sure, and then you can write it on this one. You know, whatever you feel comfortable with, I'm fine with that. Okay. So, and because of this is a small class and you've been here, you don't have to show your IDs and stuff because I've seen each of you now at least a couple times, so I should be able to do that, identify that. So any questions about the meeting? Any questions about the exam? Okay. And so, I mean, even if you're in a loud place, go ahead and leave the microphone on so I can record that. I'll mute my side if it gets loud and noisy, but we'll see. Okay, so that being said, any questions?
Yes, I had a question.
Yes, question.
So would it be best then to just go ahead and print out the exam?
I'm muted. Ha.
Can you hear me?
I can hear you now. Yeah, I muted.
Okay. Is it best to just go ahead and print out like a copy of the exam and then do that and then scan it in as we did before, or are we filling in our answers like live on there?
No, what you'll be doing is I will upload it onto Canvas right before the exam. So I want you to actually have it as a digital copy in front of you and only write down your answers on the paper.
Okay.
Okay. So I'm just going to need your name and whether you're 4333 or 5333 on the top of your document.
Okay.
And from there, I can go question 1, what I think the answer is, and what your logic was in getting your answer. Okay.
Okay, so I think I heard you say that, yes, we don't necessarily need to print out the exam, but writing it down on a separate piece of paper, you know, legibly is what you're after. Well,
for what you turn in is going to be, you know, question 1, and then you have to answer those, basically those 7 questions that are on the email. Share 9 peak, going all the way down to proposed structure. And then I want you to circle your final answers for empirical formula, hydrogen deficiency index, and structure.
Yes, sir.
That way, I know that you have circled exactly what you want me to grade.
Okay.
And then I'll look at everything else and say, oh, you know, that was close, but oh, here's the fragment you missed or something like that. And so we can improve.
Would it be in my best interest to make sure my printer is working accurately today? Let me ask that question.
Again, you don't have to print it out, and it's only going to be posted right before. Literally.
Okay, I didn't catch that part. That's what I was trying to find out.
Will only be posted to Canvas at like 10:59.
Understood.
Okay. So, and so when you set up your secondary device, I actually want to see the exam on your screen and see your book and your spare paper and your calculator that you're going to be working on, so that it's kind of giving me a side view of all that, and so I can see you work away.
Okay, yeah, I'll have to discuss the secondary device with you maybe outside of class.
Okay.
Thank you.
Yeah, just ping me after this. Actually, I have a meeting at 1:15, but other than that. Okay, will there only be problems, no questions about instrumentation? Yes, there will only be problems. There will be 5 problems for the undergraduates and 6 problems for the graduate students. And so the graduate students will, you have your different document anyway. In Canvas site anyway. So I'm going to upload your exam to your files. The undergraduates have a different Canvas site, and I'll upload their exams to their files. And that's where we'll all watch it while it's live. Okay. So usually small groups, this works okay, but go ahead.
I think Jennifer had another question about muting other people.
You should be able to mute your side. Wait, hold it. You shouldn't be able to hear anybody else, because I think I have the ability to. Uh, hmm,
I think you can also just like mute your computer altogether.
yeah. So, because you can turn down the volume on your device, but it still keeps your microphone on. So your secondary device, if you turn your volume down, you won't hear other people, but I can still hear what's happening in the room. So the idea is that, you don't have Emma on the other side of the room saying, no, wrong fragment. No. Okay. So, okay. So that should solve that problem. Okay. Oh, I didn't see the second half of your question, Jennifer. That's what you're talking about, yeah. So no, yeah. So I think that should cover your situation as well. Yeah, trying to find good internet sometimes is hard. And so finding a safe location is always difficult. All right, questions over the administration of the exam. Okay, so now let's go back and review a couple things. What I want to do is actually kind of run through the answers we got from the group session. And so I'll show you my thought process on how we did. I think most of you got almost everything right, which is great. But what I'm going to do is I'm going to pull up the answers that should already be posted. Let me double check that. Files. Activity 1, activity 2, key. There we go. So I'm going to go ahead and share my screen. Okay. No, not that one. That one. Okay. So, all right, let me move you off here. Okay. So again, what the first thing I would write down for this one right here is probably chlorine, because of that pattern there. That is a unique pattern. It's in the book. If you're not sure, and you start seeing a pattern, especially in M1, M2, M, M1, M2 peak, there's that table in your mass spec about different halogens and how they line up. Remember, only chlorine and bromine have isomers. Iodine and fluorine don't. Okay, so I'm thinking right there, chlorine, and then I look up into the other one and I see very weak peaks up in the one, so it's probably a very small molecule. And only strong peak here is a carbon-carbon double bond. So we're looking probably for a carbon-carbon double bond. And I would take that 110, subtract out, let's see, 70 from it. And that would give us our first molecular ion, which would give us our C3H4 from that. And so from that, I would build a double bond and try to figure out where to put the chlorines. Notice this is the actual answer. One of them is on the double bond. One of them is not on the double bond. I actually think that that's suggested by the fact that you have the larger fragment actually has a chlorine on it still. So that one of those chlorines clipped earlier than later. And I'm thinking it was the one at the end, the primary one is the one that clipped, leaving the chlorine on the vinyl position, telling us that would be there. What page is the table on for? Okay, the mass spec with the halogens is on figure 129 on my version, which is the 7th edition. That's page 36. And so there's a table here of different halogen mixtures. It even has, 1 chlorine, 2 chlorine, 3 chlorine, plus it also has bromine chlorine mixtures. And it shows you that on that table. Okay, did you get that? Figure 129 in version 7 It's on page 36 in version 7. So really, if you got everything perfectly right, that would be a 95% on there. If you had the chlorine in an odd place, less than 5% off, because really that's only a suggested position. It's not an absolute position. NMR would have told us perfectly, because we would have had 2 protons unsplit on an alkene and 2 protons unsplit on an alkane, and we would have known for sure that it had to be the structure. Okay. So moving on to my thought process on number 2. Right away, we have an amine with 2 hydrogens on it, or a nitrogen with 2 hydrogens on it at least. And we have a very strong parent ion peak, and it's odd. That also tells us we have 1 nitrogen or more. The fact that it's such a low molecular weight means we probably don't have 2 nitrogens. So I'm suggesting we have 1 nitrogen, and the remaining of the mass is that carbons, oxygens, and hydrogens. We see the very strong but broad peak below 1600 in that 1681. That's suggesting it was some kind of carbonyl, but of that series of carbonyl, remember that the carbonyl with the chloride on it, which is the strong electron withdrawing group, is at higher frequencies. And once you get donating groups and or the carboxylate salts, that's lower wavelength. So that's what's shifting that carbonyl down from that classical ketone at 1720, 1725. So that suggests that we probably have an electron donating group somewhere near the carbonyl. Okay. So from that, we can say, okay, well, we only have everything else. We don't have much else. Then we see a classical peak at 43. 43 is our classical carbonyl with a methyl group on it. Okay, we see that a lot in terminal methyl ketones. We see that a lot in anything with an acetyl group or an acetyl ester. We're going to see that peak as one of the major peaks. Okay, so we have a nitrogen with 2 hydrogens on it. We have that 43 peak. That's all our mass. So we have to stick those together somehow. And the broad peak at the 1681 supports our idea that we have some kind of amide structure or some kind of donating group on the carbonyl. So we have the amine, stick it on the acetyl group, and we have the acid amide. Okay, so that should have been fairly straightforward. However, the broadness of that peak might have given you a little concern. But when you can actually read on amides in the book, and it'll actually say that this peak can be broad, but the 2 peaks up in the nitrogen, up in the high level, up in the 3300 range, should definitely say you have 2 hydrogens there. Okay, on the next one, my approach here was, wow, not much there except for that 1715 on the IR. So we probably have some kind of ketone. All right. Then we look at the mass spec, and we have the 43. So we probably have some kind of acetyl or methyl ketone. And we have a 91, which means we have some kind of benzyl group. Okay. Now let's calculate our mass. Once we do our rule of 13, we're looking probably at 10 carbons. And then we have a carbonyl, so we need to replace at least one of them with oxygen. That gets us to our empirical formula of C9H10O. But we have definitely, that 43 tells us we have that carbonyl and methyl group that can cleave off something that gives a strong 91. So that puts those 2 fragments together. And so we have major fragment 91, major fragment 43. They fit together to make our perfect C9H10O. And there's very little else in the spectrum there. That notice that carbonyl is really, really strong, and those CHs are weak. You know, that's only because that carbonyl is so strong that you would actually, you know, kind of adjust the spectrum to make the 3000 peaks bigger if that carbonyl wasn't so strong. But the fact that it is so strong, it kind of pushes them up to the top of the All right, questions on that? Now, this one right here, the key here was looking at your molecular ion peak and saying, you know, it's pretty tall for a molecular ion peak. Okay, and then by mass, we have a C5H10, and by our IR, we don't have a CC double bond. Okay, we don't have a CC double bond, but we have a hydrogen deficiency index of 1. Remember, hydrogen deficiency index count for 1 double bond or 1 ring. So that's why benzene has a hydrogen deficiency of 4. 3 double bonds, 1 ring. Okay, so the fact that we didn't have the carbon-carbon double bond in this thing told us that we might have a ring, and that parent ion peak's a little strong for that molecular weight, so that would also tell us that. It also tells us we don't have a straight chain because we didn't see the classical 14, 14, 14, 14 cutoffs, so we didn't have a straight chain either. Okay, I think that's the last one. Yeah, so that's the way I attack the problems. And, you know, once you get some, you know, initial ideas together, then you start doing the down and dirty and getting the, you know, empirical formulas down, and then the substituted formulas down, and then you calculate your hydrogen deficiency index. So notice that on this last one here, if we didn't calculate our hydrogen deficiency index, we wouldn't know we had it of 1, and we wouldn't be looking for the ring. So we had to calculate the hydrogen deficiency on this last one to be able to do that. And the hydrogen deficiency index here would actually be 5, because we have 4 for the benzene ring and 1 for the carbonyl. And the hydrogen deficiency index here should be 1, and the hydrogen deficiency index here should be 1 as well. So
that question on the last problem.
Yes.
So I did the hydrogen deficiency. I got it of 1. My structure was totally different. I guess my group, we agreed on a different structure, but because of the hydrogen deficiency of 1, the rule is that 1 dictates there is a ring structure of some sort. Correct? I'm trying to get that straight.
A double bond or a ring.
Double bond or a ring. Okay. Well, I proposed a ring, but it was just smaller. So I'm just wondering what the difference is between having a full 5-membered ring versus a 3 with an ethyl coming off.
3-membered ring with an ethyl would be supported by all the evidence here.
Oh, really? Okay. So
you get at least partial credit for that. I mean, most credit.
Okay. I mean, it's one of those areas that you've spoken about.
Yeah, it could be with this particular ring. We cannot tell because the cyclopropyl ethyl, the cyclopropyl with an ethyl substituent would give practically the same IR and the same mass spec, because your 42 is your 3 carbons.
Right. So I guess what I'm asking is, how did you get to this ring structure? Because we never even proposed that one, and so I'm just trying to see your thought process on that answer.
Simplicity. It's the first ring you can make.
Understood.
So you know, again, Occam's razor: go to the simplest structure first.
Okay, now I'm with you. Yes, sir. I have seen contact.
And the other suggestion I would give there is, the cleaner your IR spectrum, you start looking for symmetry. And so, you know, because there are less overtones. Once you have a symmetrical molecule, there are less overtones, there's less things happening. So that's just empirical. That's why you'd probably get most credit, maybe just a couple points off for that, because you satisfied our hydrogen deficiency index, and there's nothing that does not support your proposed structure.
Thank you. That makes complete sense.
Okay. All right, other questions about this set, or the kind of concept of how the thought process works? Let's see. Okay, so let me go ahead, and if you have a question, go ahead and chime in. Yeah.
Yes. Can you explain more further about like how the clean IR looks like. Like I can see the one, but still, can you explain it more? So
Yes, I have. In fact, in your homework set, you had an example of this where you were given, oh, let me look at your homework set actually. I have the homework set key here too. Homework, where's the homework key? Oh, I didn't post the homework key yet. Oh, let me pull up the homework key because I think I have a great example of that. Chapter 1, Chapter 2. Oh, I didn't publish my homework key, did I? Oh, I haven't graded it yet, that's why. There was an example in the homework key with one that was very symmetrical, and let me pull it up right here. Okay. I know I gave you a cyclic in your homework set. Just can't. Oh, it's O.
we have spectrum E, F, K, J in IR homework.
Mm-hmm.
So if you are looking for these one too.
K, E, F, G, is it I? No, that has a carbonyl on it. Okay, I don't have a good example for that right now. But the idea is, you know, the more simple, the more symmetrical a molecule is, the less different types of frequencies you're going to have, right?
Okay.
You have, you know, like acetone, it's very simple and it only can vibrate in a couple different ways. You put an ethyl group on here, now it's unsymmetrical. Now you're going to get an unsymmetrical wag on it. And so the more symmetrical your vibrations are going to be, because the mass is same on each side of the different bonds doing that pull. Okay.
Like
So,
more the number of carbon atom, the more the freedom of vibrations.
correct. And so, and it, you know, each one's gonna, you know, if it's symmetrical, then you're gonna have these two are going to overlap with these two, are going to overlap with these two, and so they're going to have fewer vibrations than if it was unsymmetrical, because none of these are going to be at the same energy. So you're going to have multiple ones or spread out a band. That's my explanation of that for now.
Yeah, I think it's spectrum G as well. That one just popped out at me. I think I agree with Marvin.
Yeah. Spectrum G, and that is an alkyne. No, a 30.
Page,
oh,
page
no.
112.
Yeah. G as in goat. K, which is a bit noisy. Yeah. Well, I mean, part of that smooth baseline is sample prep. Oh, I see what you're talking about. Oh, yeah. The number of frequencies versus one looks a bit.
I think that's the one.
Yeah. Yeah. Yeah.
Marvin caught it. It's Marvin.
That's it. That's it. And then also, yeah, there's another one of these that pairs up really well with one of the more symmetrical ones. from the mass spec. There's one that pairs up with the structure O on the mass spec, because you have this ring with just an OH on it, and the OH clips off first and then gives you that cyclohexyl ring, and that's always nice and clean. Yeah, I'm sorry, I don't have a readily available structure for that.
Could we walk through G? Would that be okay?
Okay. Does everybody G on IR?
Seems like a lot of people have questions on it.
All right, let's go ahead and walk through G on IR. Okay, so we have something above, but everything below. So we only have aliphatics. We don't have, well, we have something at almost 1600, but we have no alkyne. We have no carbonyl. We might have a carbon-carbon double bond, but we don't have any sp2 hybridized carbon hydrogens. Okay, so let's see, what can that 3300 peak be? So that could be, if we prepped our sample, it could be maybe a small OH or a small amine. Let's see what else shows up in that region. I don't think anything else shows up in that region. It's going to be a small atom, large atom, but it's not alkyne because it's not sharp, and we don't see something in the 25 range. It's not an aldehyde because we don't have a carbonyl. We don't have a 2700 peak. So let's see what we have here. And it should correlate to one of the structures on the page on 39 on exercises here. So let's see, what could we correlate it to? It's none of those. Ooh, there's a maybe here. Remember that we can decrease the amount of hydrogen bonding with alcohols by diluting the solution. So by diluting the solution, you get less hydrogen bonding between alcohols. And another way is to have maybe it as a tertiary alcohol. So I think if we had a mass spec correlating with this spectrum here, I would think it might be a tertiary alcohol here. Actually, let's see, I might have, no, that's not the right one. Let's see. Student exercise. Let's see, spectrum G. Can't be it. Yeah, I'm thinking it would definitely have to be either a tertiary alcohol or an alcohol that's been set up in a very dilute solution. The other would be an amine with a single hydrogen on it. Okay. So I think those two are the most promising ones there. In looking at the structures, though, it should correlate to one of the structures from the previous one. We don't have an amine on exercise 1.1. And so really these IR should correlate to the things in exercise 1.1, and they should be answered from that. So I'm gonna have to go with a tertiary alcohol of the structures available to us on page 39 of my book, which is exercise 1.1. I'm gonna have to say it's gonna be the tertiary alcohol of I in my book.
I have like one question. Like
Mhm.
in 2.9 question, they were saying that the structure are listed in exercise 1.6.
1.6.
So if you relate the spectrum G and 1.6 and 2.9 G, there is an odd peak.
Oh, G is, oh, there is an odd peak in there. So it can be a primary mean. All right, if it's a primary mean, well, no, it has to be a secondary mean. It's a completely aliphatic secondary mean. So, yeah, I think that you're right there. Because there's two different odd peaks. There's B and J and U. So there's three different possible odd peaks. I think it's a low molecular weight secondary mean. Mine is the 7th edition, so it could be page 40 on the 8th edition.
Is it fine if we like don't know the exact position of a mean, the secondary, primary sort of thing? So if we got confused with the primary mean and the secondary mean, is
Right.
it fine at that position?
Well, primary mean is going to have two peaks because
Okay.
each of those hydrogens there's two different vibrations. One's a wag and one's a stretch.
Okay.
The primary, the one with only one hydrogen on it, I'm sorry, the secondary, which only has one hydrogen on it, only has one vibration mode in that range. And so when you have no hydrogens on it, it won't show up in that range at all.
Oh.
So I think you're right. I think it's a secondary amine, a straight chain aliphatic secondary amine, like a methyl ethyl, methyl propyl, ethyl propyl, something like that. Yeah, because those match. Yeah, because the ones in 1.6 match that.
So one more question. In amide, the peak for the amine will be broader than the primary amine?
In an amide,
Yes.
it can be. It's all about how many hydrogens are on there and the strength of the other peaks. So again, if you only have two amide hydrogens and you have a whole bunch of aliphatic hydrogens, the peak's going to look smaller, but it's still going to be in that 3,300 range. And if it has two hydrogens on it, it'll have two peaks. One hydrogen will have one peak. On this spectrum, we definitely don't have a carbonyl, so we definitely know it's an amine and not an amide. Okay. Yeah, I should probably post the results to that 1 and 2.
I also had a question on the mass spec section on page 42 for the 8th edition. It was the mass spec for J. I noticed that there were some peaks on the lower mass range that were really close to each other that couldn't be a loss of carbon or oxygen. And it made me think of instrumental analysis, where we talk about a way to mathematically relate peaks and understand whether or not certain peaks are related. Because you see like a clipping at like 39, I think, and 44, and then 51.
Right.
Would that be a useful way to try to understand that?
So yes, what you want to look for is, I mean, those are peaks found. And so you want to look at the difference between them and if they correlate to cleavages above. So those fragments down below had to come from somewhere. So were they clipped off regularly, or did they decompose in a different way? Okay, so for example, there's this huge gap on this particular one between 138 and 107. Okay, That's the first big jump, and then there's this 94 peak. Okay, so that's telling us something big fell off first. Then it looks like the rest of it is fragmenting from that. And 39 to 45 is only 14. Oh, 15, 16. No, it's only, oh, it's only 6. So it can't be, that can't be an individual atom. So what you're looking at is, you know, these are fragments that are lost. Those individual things aren't breaking apart themselves. Okay, so you need to look at what 39 would be, what 41 would be, and what 51 would be. Now, we don't see those different fragments breaking off regularly, but we do have the 91 to 107, which is 13. We have that 77 to 94, which is 20 minus 3 is 17. So we have odd distribution of these cleavage points. So our fragment losses are not matching the fragments seen in that lower end, right? So what we have to do is then start looking at what our major fragments are and start seeing if we can piece those together based on our empirical formula. So at 138 molecular weight, we're looking at, you know, empirical formula starting around C10. And so that could be, well, it's probably not, well, we have a 77 peak. So it could be a benzene with something on it. And that would account for having small fragments falling off the outside. You're allowed to use all the tables in the book on there. Did I answer your question, by the way?
Yeah, I had one other side question with it. Is it possible to start off with a ring that, as it's fragmenting in the mass spec, it then forms a benzene ring? So you may not start off with benzene, but you end up with it somehow?
Only if you had the double bonds already on the straight chain. Okay, because you're not going to lose, you're not going to aromatize by that. So you would have to have like a hexatriene that then cyclizes in the system. Okay, so I think going off and looking at a hydrogen deficiency index, starting with our, let's see, it would be a C10H18 would be our empirical formula starting here on this particular one, and see what our hydrogen deficiency index would be on that, and go from there. If we don't get a hydrogen deficiency index of at least 4, we know it doesn't have a benzene ring, and that's a different fragment. So, and that 77 is not really strong, I would think, but. Yeah, and so the 3 most important appendices to look at are, of course, Appendix B in mass spec, Appendix C in mass spec, and just the functional groups section of, like, which is the Appendix B under characteristic absorption groups. But I would look for only the ones that say strong. You know, if they're weak, you're looking for them as secondary validation, but look for the ones that say S above them, which signifies strong. Those are the ones you'll always see. Things that are medium or weak, you might not see. So you don't want to hang your hat on a weak signal. You don't want to count on a weak signal defining you. And let's see. I also like my table of those 4 zones of the different, where the different bonds show up. You know, your heavy atom, light atom, high frequency bonds, your triple bond area, your double bond area, and then your single bonds area. because that should get you thinking along certain functional groups right away. Okay. So if you want to hang on and test your secondary device, if you already have it loaded and you have the email with the link on it for this one, the one I sent the email with, I'm going to go ahead and open that up on my end and see if we can start all chiming in on this one. Join. Oh, I need to figure out the meeting ID. And let's see, the meeting ID. Oh, I put a passcode in it. Let's see, I have 92323240866. Join. Connecting. Use internet audio. And I didn't have to use the passcode. That's interesting. Oh, I guess because I'm starting it. So let's see. Okay. All right. Emma's got hers logged in. Oh, see, and that's a good location right there. So I can see what Emma has is it's probably about 24 inches away. I can see her computer screen, her book, and her scratch paper. Okay. And I'm trying to put mine here so you can see my computer screen and my stacks and stacks of books there in the background. Emma, did you have to add a passcode to the Zoom portable one?
If you click on the link straight away, then you don't have to.
Yeah, okay, I put it in. I guess I'm logged in as me and I'm the meeting organizer, so I guess I didn't have to put it in. So Emma, definitely you're set up correctly there for sure.
I feel like mine will be hard to see my laptop screen from just because of that window and the lighting. I don't know if you can see me now.
Are you online here? Oh. Let me look at all participants. Okay, I'm trying to. All right, so yeah, even with that on there, I can see your screen, I can see your work surface. And so if you had your book right next to you, I should be able to see everything from that. I mean, I can't read your computer screen, but I can definitely see where you're working. So that's working really well. Okay, and I can go from view to view here. Okay, so let's, okay. And all right, and Jennifer, I can see your computer screen, your book, and where you're writing. That's perfect. Let's see, I got another one here. All right, yeah, Megan, I can see the computer screen, the scratch paper, and the book just fine. Marvin, I can see the computer screen. I can, well, if you tilt it a little, yeah, there we go. Yeah, so I can see what your files open and all of your notes in your book there. That's great. Almost, okay. Okay. Iram, push it a little further back and a little down. Oh, see, see right there. See, now I can see your computer screen and your book and your work surface right there. That's perfect. Okay. So, oops, that's not, no. Go back. Okay, so let's see. So yeah, everybody has that set up correctly. So that, yeah, now that window is not that bad. So, okay, great, great. So, all right. So, I think that worked out really well. So overall, anybody who wasn't here, we can go and do that separately as well. Okay, I'm going to go ahead and close out this meeting and go ahead and go back to the main meeting. There we go. So cool. Actually, every Monday morning, I see one of my students in one of my classes, and they're in the passenger seat. They're driving probably 90 miles an hour down the highway. Somebody else is driving, but they come to class. They're just, I can see the stuff in the window going. So the zooming by phone does work a lot, pretty well. Okay. All right. So, all right. Any other questions? I think that worked out really well. So we'll consider that how we're going to do this. Again, I will release this right about 10:59, and so that you can kind of get ready to log in with your phone and get ready with your computer, and then we'll go ahead and open that up. I'll open it up actually on my computer because I have multiple screens, so I can do that. And I won't be on the mobile call. I will open up the mobile call on my computer. And so you should be able to see me. And what I'll do is I'll actually put myself off camera and mute myself and just kind of record the session. But if you have a question, go ahead and unmute or type in the chat, and then I can answer your question. And you can do private chat if you want to ask a specific question just to me, or you can do to everybody. I can see all chat even if it's private, so don't do that. So, and it records it too. It records the chat as well. Okay, any questions? Okay. So, well, we are a little early, but I can stop recording, and so that now we have this instructions that you can go back to. I'll post those on our YouTube channel so that you have the instructions as well if you want to review them. So let me go and do that. Stop sharing and stop recording.